Good morning, everyone. On behalf of the organizing committee, I extend a warm welcome to all the distinguished guests, speaker, and participant present here today. I am Professor Jayashree Dongre, Assistant Professor of Dr. Rajendra Gode Institute of Technology and Research, Amravati, and I am the coordinator of today's conference. It's a pleasure to welcome you all this event. Now inviting another coordinator, Miss Pranjali Rangari ma'am.
Please, ma'am, unmute yourself.
Yes, sir.
Pranjali, I request you to unmute yourself. Your voice is not.
Ma'am, voice is not clear.
Please unmute yourself.
Yes. Sorry.
Yes, now.
It's good now.
Hi, I'm Mrs. Pranjali Rangari, and I'm also coordinator of today's conference. It's a pleasure to welcome you all to this event. On behalf of SCI Craft Hub publication, I extend a heartfelt welcome to the International Online Conference 2025 on theme Global Research Frontier to 2025, Innovation, Sustainability, and Digital Transformation. Today's conference brings together researchers, students, industrial professionals, and academicians from diverse disciplines to share their innovative work, exchange idea, and explore future research directions. We are honored to have with us our chief editor, distinguished advisory board member, and a vibrant community of present joining us from across India and abroad. Now I'm inviting coordinator 1.
As we embark on this academic journey, it gives me great pleasure to introduce and warmly welcome Dr. Sneha Kharse ma'am, our Chief Editor, Conference Chair and Organizing Chair, and the visionary founder of SCI Craft publication, Dr. Kharse ma'am, unwavering commitment to scholarship, mentorship, and innovations has been instrumental in commitment to scholarship, mentorship, has been instrumental in shaping this conference. Here, leadership has transformed idea into impact and brought this platform to life. Please join me in extending a heartfelt welcome to Dr. Sneha Kharse ma'am. I also extend a warm welcome to our Chief Patron, Professor Rizik Sir, Professor of Physical Therapy, Department of Physical Therapy, Faculty of Medical Rehabilitation Science, King Abdulaziz University, and patron Professor Diani Ma'am, Assistant Professor of A.L. Mustafa University, Colombo, Sri Lanka. Now it's my honor to introduce our Technical Chair and Evaluation Committee Head, Professor Rohit Sarode sir. He has completed his PhD, MTech and BE along with several distinguished certifications including DMCAT, FIAS, DIH, DIAJ, and DIABM. Currently, he serves as an assistant professor in the Department of Mechanical Engineering at Dr. Rajendra Gode Institute of Technology and Research, Amravati, Maharashtra. We are privileged to have his guidance and expertise for today's conference. Please join me in welcoming our advertising board members, Mr. Abhinay Sir, software developer and guest lecturer, Artificial Intelligence, Vidyanagar, Karimanagar, and Telangana. Dr. Anita Ma'am, Assistant Professor of Economic, Lady Dock College, Mudrai, and Professor Ahmed Sir, Assistant Professor of Digital Marketing, Faculty of Business, Middle East University, Jordan. Their expertise and guidance have enrich this conference, and they will also join our interactive questions and answers to share valuable insights with our presenters. Next slide to hand over the Pranjali Rangari ma'am. Ma'am.
Ma'am, unmute. Ma'am, unmute yourself.
I'm Pranjali, conference coordinator. Let me quickly walk you through the program structure for the day. All participants will present their paper through PowerPoint presentation. Each presenter will get 6 to 8 minutes only for presentation, followed by 2 minutes of question and answer. Technical chair and evaluation committee head and advisory board member will be interacting with presenters during question and answer, providing critical feedback and suggestions. After all sessions, we will have a best paper award announcement. E-certificates will be sent to all participants after the event. We request all presenters to stick to the time limit, keep their PPTs ready, and ensure their microphones and internet connections are stable. So, introducing paper presentation session. Now we will begin with the paper presentation sessions, starting with paper 1. Samyak and team, I request the first presenter to kindly share their screen and start their presentation.
सम्यक सम्यक unmute.
Good morning, everyone. I am Samyak Ingre. I am a third-year student of Department of Mechanical Engineering at DRGITR. And these are all my team members, Gaurav Gane, Shantanu Metkars, and Deep Kolle. And this presentation is done under the guidance of Professor G.S. Dongre ma'am or Professor M.R. Dhavde sir. We are presenting on topic of conversion of 4-stroke engine into 6-stroke engine by epicyclic camshaft modifications. First of all, these are the contents of today's presentations. Now we are starts from introductions. Gaurav Gane.
Introduction.
A new method to improve efficiency by converting 4-stroke engine into 6-stroke engine by using a camshaft mechanism. A very simple line that show in the above topic, that is conversion of 4-stroke engine into 6-stroke engine into epicyclic gearing mechanism. Camshaft means complete one power cycle into 4-stroke, and 6 strokes means one complete power cycle with adding 2 extra stroke. That's why we called as conversion of 4-stroke engine into 6-stroke engine. Then next, types of 4-stroke. Types of 4 strokes means complete one power cycle in 4-stroke. Means diesel engine, CNG, LPG, then petrol engine. Petrol engine is used where term the cars and vehicles, and diesel engine is used heavy vehicles and trucks, and LPG and CNG is used to modify the version of gas and fuels. Now literature review. Literature review. Literature shows the six-stroke engine whose efficiency and cut emissions by adding two extra stroke for heat recovery as demonstrated by Crower and Beer modes. Now I hand over to slide Deep Kolle.
Advantages. Converting a four-stroke engine to a six-stroke engine using ethically generating in a camshaft can increase in thermal energy, reduce fuel consumption, and low efficiency. And second disadvantage, releasing to mechanical complexity engine performing the cost and practically increasing mechanical complexity. The 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 additional of a ethically gearing train planetary gearing sets to the camshaft significant increasing the complexity of the engine design and assumptions. Now hand over to Gaurav Khani.
नाही झालं काय थांबलं नाही थांबलं ते थांबत तर आलं सुचतं मध्ये त्याला थांबत होतं.
शंतनू मेटकर. The aim of the project is to convert the conversion of four-stroke engine into six-stroke engine. Objective of this project is to design and implement an efficiency gear machines that allow the camshaft speed ratio for four-stroke operation. The future scope of the non-converting four-stroke to six-stroke engine lies in their potential for increase the future scope for non-converting four-stroke to six-stroke engine lies in the potential for increased fuel efficiency and reduced emission by utilizing waste heat. While the purpose of the project is to convert value time and value lift and the duration in internal combustion engine. Design consideration is the smooth operation, proper lubrication, and material hardness. The actual machine of cam profile, balancing, reduce vibration. Material used in this, the cast iron for the good wear resistance. Second, alloy steel for the high performance engines. Third is the used cast iron for the hardness surface durability. The result of this is the stroke engine can improve fuel efficiency and reduce emission by using waste heat. While several six-stroke engine concept exist, the technology remains in the research. Thank you. Samyak. I hand over the Samyak.
Sir, PPT is
Ye-
over.
Yes, ma'am. Next.
Okay. So the paper presentation is done.
Yes, ma'am.
Uh,
Yes, ma'am.
Yes, ma'am.
we now please anyone have any queries and questions? So they can ask and questions to regarding to the presentation.
Just, I think the coordination not good between the student, but just clarify one point. What is the main aim of this project? Hello, I'm audible now?
Yes, sir. Yes.
Yes, sir, you are audible.
Just
Sir,
clarify one point. What is the main aim of the project?
actually, the main purpose of this aim, actually, to convert the four-stroke engine into six-stroke engine by converting a gearing in camshaft mechanism to improve efficiency and reduce emissions. So this is the main
So
main
what is
aim
the
of this.
advantages of six-strokes engine?
The
Sir,
advantages
okay.
that
You can.
the advantages the advantages of six-stroke engine is to improve thermal efficiency, reduce fuel consumption, and lower external temperature. Okay.
Okay, and disadvantages?
It it has a higher mechanical complexity and lower power output due to fewer power stroke.
What is your viewpoint related to the future scope in a six-stroke engine?
The future scope is they offer the potential for higher fuel efficiency and lower emission, but face challenges of cost and design complexity. Okay, done.
Okay, Pranjal ma'am. Done ma'am on my side. I think it's move in next presentation.
Move to the
One
next.
minute, Pranjali, 1 minute. 1 minute. I asked you, Auditor sir, if you have any question, you can ask to the presenter. Are you there, sir?
Yeah, yes, madam. I have them.
Yeah, please ask the question if you have, sir. Okay, sir.
Okay. What is the cost efficiency for the implementation process of the technology you have done with your project? Hello? Hello, Gaurav.
Yes.
Yeah. What is the cost efficiency and how we will going to implement it?
Process convert the input material um, in Samyak.
Can I?
Yes,
Hello?
please.
Hello?
Yes, sir, ma'am.
Sir, sir, can I repeat this question again?
Yeah, yes, sir. What is the
Hmm?
efficiency cost efficiency?
Actually, sir, as we seen through the four-stroke engine are generally most efficient for fuel and long-term use.
Okay.
And as we see for a six-stroke engine, the fuel economy is better and emission is better than the four-stroke engine, because we are using one power of cycle in four-stroke engine. That's why we called as four-stroke engine. If we are taking six-stroke engine, in that we are adding two extra stroke.
Okay.
So
Also,
that's why it's cost efficiency more than a four-stroke engine.
Yeah, yes.
sir, also it consumes less fuel for same power output. It has better thermal efficiency. Lubricant oil consumption is low, less wear and tear.
Okay, thank you.
Done.
Done.
Any question?
Any questions?
No, madam.
No,
No. Now we will step up to the next paper presentation sessions. Name Guru Belli sir. I request to kindly share their screen and start their presentation. Mr. Guru Belli sir, are you there?
I think not join now.
Oh, okay.
I think moving next presentation.
So, move to the next presentation. The Anand and team kindly share their screen and start their presentation. Mr. Anand and team.
Yes, ma'am.
Oh.
And good morning, everyone. My name is Anand Gunwanta Bagde, and my topic title is Performance Evaluating Fuel Efficiency and Wear and Longevity. This presentation is performed by Kunal Bise. My teammates is Kunal Bise, Om Bise, and Subodh Bhagat, under the guidance of the Rohit Sarode sir and Giridhar Shendre sir. And these are the contents of this presentation: importance of moped engine, objectives of the study, lubricant types, methodology, and remaining. Then let's move to the introduction of the topic. The title is Impact of Lubricants and Moped.
Sorry for interrupt, Anand.
Yes, sir.
Anand, I think your audio, you have joined this meeting in two device, I think. That's
Yes,
why
sir.
audio are.
Yes, sir.
Your audio not clear.
One minute, sir.
Please continue, Anand. Oh,
Uh, hello. My topic is impact of lubricants on moped engine performance and evaluating fuel efficiency. In this topic, we focused on understanding how different lubricants influence the performance of moped engine, compact engine that operate under high stress, making effective lubrication essential for reducing wear, improving fuel efficiency, and increasing engine life. We compared various types of lubricant through field testing and performance analysis. The result showed that using the right lubricant not only enhances engine performance and longevity, but also supports sustainability by reducing emission and improving overall efficiency. And the remaining presentation can be carried out by Kunal Bise.
Morning. I have the topic the objective of the study. So in this we observe the key points. Properly, the lubricant is heartbeat and of the engine. The lubricant play a wide role in the keeping engine running smoothly and efficiently. And these are mainly three types of lubricant. First one is synthetic oil, and the second one is mineral oil, and the third one is blended oil. And lubricant greatly impact engine components such as piston, cylinders, valves, and gears. They reduce the friction present wears and ensure smoothly operation of the moving parts. Here the I am handovering the slide to the Om Bise. Good morning, sir. Next topic is methodology. Methodology is a system of methods, rules, and principles used in a particular discipline or the study of the method. There are seven methods. First one is scope and sample. Second is test roads. Third is control. Fourth, protocol. Fourth is instrumentation. Fifth is data log. And seventh is QA. Then the next topic of methodology is a measure, wear, and analysis. There are also 6 points. First method is a fuel efficiency. Second is a wear checks and non-tear down. Third is oil condition monitoring. And fourth is longitudinal proxies. And fifth is start plan. And sixth is safety and compliance. And then the next topic is I can hand over to the Subodh Bhagat.
Hello. So let's move on to our final topic, that is result and conclusion. So we got result from this entire project, that is fuel efficiency of synthetic oil. We get 54.2 kilometer per liter and blended oil 51.0 kilometer per liter and mineral oil 48.3 kilometer per liter. And you can show that is graph of the of our project. please cite the slide. And now we are concluded that from the entire project, that is synthetic lubricant deliver the best overall outcome in field use, higher fuel efficiency, slower wear progression, and steadier engine health. The blended oils offer mid-level performance, balancing cost with measurable gains over mineral oils that is trailed on efficiency and wear, leading to earlier maintenance triggers and shorter service intervals. And you can see the reference of our topics. Thank you.
Thank you for the presentation. Now we invite our advisory board for their comments and any questions.
The result were communicated very clearly, but again, coordination issues are there. But anyway, what makes the lubricant is especially important in moped? Anand, I'm audible, ma'am?
Yes, sir, you are audible now.
Yes, sir.
Sir, can you
My
repeat the
question
question?
is my question is, what makes the lubricants especially important in moped?
Yes, sir. The lubricant is important to reduce the friction and heat and protect the parts of the engine and improve efficiency of life smash.
Which lubricant types give a best fuel efficiency and by how much? Can I repeat again? Which lubricant type give the best fuel efficiency and by how much?
Sir, synthetic oils give 54.2 kilometer per liter and beet mineral give 48.3 kilometer per liter by approx 12%, and blend were made with 51.0 kilometer per liter, sir.
Okay. How do you do measure wear and engine health?
ICP wear metals, example FEPPM, magnetic ring plug debris, endoscopic checks, compression test, and oil condition. Example viscosity 40 to 100 centimeter degree centigrade, TBN, 1TN, and FTIR.
Okay. My last question is, what is the bottom line recommendations and next steps of this project? Means what is the bottom line recommendations and next step?
So, smoother operation consider like blends for cost balance, extend to extreme condition, text and leader down where mapping emissions and fleet scale RCT plus LCA.
Okay, okay.
These are the recommendations of next step.
Okay, done. Nice response and okay, Pranjali ma'am.
Thank you for your presentation. Now we will step up to the next paper presentation session. Name Vaishakhi and team. I request them to present their PPT and share their screen and start their presentation.
Good morning, everyone. I'm Vaishakhi Nalat from DRGITR Amravati, and our project under the guidance of the Jayashree Dongre ma'am, and our project Design and Modified Four-Stroke Four-Revolution Engine focuses on the improving efficiency and performance of conventional four-stroke engine. And typically, this engine utilizes only about 30 to 35% of the fuel energy, and while rest energy lost and in the form of heat and friction. And our design introduces a modified and crankshaft mechanism that allows the smoother operation, and this innovation aims to reduce energy losses, increases the efficiency, and increases the overall performance and energy efficiency. Now I will hand over to Prachi, who will explain the detailed design concept.
Thank you, Vaishaki. In our design, the crankshaft completes 4 revolutions per cycle instead of the standard 2. This modification allows the fuel to burn more, completely minimizing unburned fuel loss and reducing friction between moving parts. Additionally, smoother piston movement reduces mechanical wear and vibration, which can extend engine life. We also focus on ensuring that the design can be implemented without major changes to the engine size or weight, making it practical for real world application. Next, Vaishnavi will be represent our performance analysis result.
Thank you, Prachi. After analyzing the modification engine, we observe several improvements. First, the fuel efficiency increases noticeable due to the more complete combustion. Second, the smooth pistons movement lead to more stable power deliver, reducing engine vibration. Finally, the 4 revolution cycle helps lower energy losses and emission, which can make engines more environmentally friendly. Overall, the performance data confirms that over modification can enhance efficiency and sustainability. Now summarize overwork and conclusion.
Thank you, Vaishnavi. To conclude, our modified four-stroke four-revolution engine demonstrate that the small change in engine mechanics can lead to significant and improvement in efficiency and performance of an environmental impact. Importantly, our approach retain the core principle of conventional engine, making it easier to adapt and implement in existing design. We believe this concept can constitute to development of more sustainable and efficient automotive techniques. Thank you all of your attention. We have welcome any questions.
Thank you for the presentation. Now we invite our advisory board and other members uh, uh, board for their comments and questions and queries.
Excellent presentation as compared to the previous presentations, nice coordinations, and very well structured and easy to follow the methodology and convey their result. But one question is, why do conventional IC engine utilize only 30 to 35% of the fuel energy?
Conventional IC engine utilize only 30 to 35% of fuel engine because the large portion of lost heat through the exhaust gas friction between moving part and incomplete combustion. Only as a small part of energy is converted into a useful mechanical work.
Okay, but in a simple term, what type of problem you trying to solve this in this project? It's in simple term, what is the problem your project trying to solve?
Yes, sir. Our project aims to solve the problem of low efficiency in the conventional four-stroke engine. Most engine were using large waste of the energy in the form of heat and friction. So we designed the modified four-stroke engine that uses less fuel and efficiency will increase.
Which control strategy, that is igniting, fueling, and change is needed to the 4 evaluation cycles?
Sir, sorry, but can you repeat the question?
Which control strategy changes are needed for a 4 evaluation cycle?
Here, my answer. Uh, for a four revolution cycle, the ECU program is to adjust the ignition and fuel injection and valve timing according to the longer cycle.
And which component change contribute to most efficiency gain and why? Which reason behind that? Means which component change contribute to the most of the efficiency gain and why?
The component is the modified crankshaft because it improves the piston movement and it reduces the energy losses and smoother operations. So it is the main component which gains the efficiency.
Okay, nice response. Okay. Ranjan ma'am, done on my side.
Please kindly question your queries and anything. Other members also. Anyone has any questions? Okay. So now we step up to the next presentation. Paper presentation session. Unnamed Dr. Anita Selvaraj. I kindly request to please share your presentation and screen and start their presentation.
Vaishakhi, please stop your screen sharing. Vaishakhi.
Am I audible? Am I audible?
Hello, ma'am, Dr. Anita.
Yes, Pranjal ma'am, am I audible?
Please start.
Your audible voice is slow. Your screen is showing.
Yes, yes.
Just a second. I hope my slides are visible.
Yes.
Okay, ma'am. Thank you to the organizers for giving me this opportunity. And my topic is bridging the digital divide, strategic roadmaps for MSMEs in emerging economies. So as digital technologies are reshaping productivity and competitiveness globally, so MSMEs in emerging economies are facing barriers. So the major barriers are infrastructure, skills, and strategic capacity. So the digital divide deepens economic inequality, and this
I'm
paper.
sorry to interrupt.
Yes, sir.
Your slide not visible, ma'am.
Not visible. Is it visible now, sir?
Yes, ma'am. Yes, ma'am. Now visible, ma'am. Now visible.
So my topic is bridging the digital divide, strategic roadmaps for MSMEs in emerging economies. So this paper concentrates on digital technologies reshaping productivity and competitiveness globally. So as if we see, MSMEs in emerging economies are facing a lot of barriers with regard to infrastructure, skills, and strategic capacity. So the digital divide deepens economic inequality. So this paper analyzes the strategic digital roadmaps, which can help MSMEs utilize digital tools effectively. So the objectives of the study is to assess impact of strategic digital roadmaps on MSME productivity and efficiency, to evaluate digital position and online market exposure, to compare sector-specific outcomes, and to generate policy implications for MSME digitalization. So the research design is like quasi-experimental study where we have two groups. One is the intervention group and the control group, and this is over a period of 12 months. So 120 MSMEs have been taken into consideration, 40 retail, 40 manufacturing, and 40 services. So the interventions, if you see it as digital roadmap, training and platform access, which has been done through skill training given to the industries, to the enterprises. So the control is like business as usual operations. It has been made under control. And the analysis is difference in differences estimation with firm fixed effects. So it's more like an multiple linear regression model. So the intervention components, if you see, one is online audit and roadmap creation, and which was done for the baseline assessment and tailored plans. The second, with regard to training capacity building, it was like weekly seminars and boot camps conducted. And the platform access and support was e-commerce, payment gateways, and help desk. So the monitoring and feedback was done quarterly, and the roadmaps were updated. So the key indicators, there are three time points. One is the baseline, the starting stage. Then after quarterly, that is midline, and the end line after a year. So the productivity was identified, output per employee, and then the digital capability was on the score of 5-point digital maturity index. And the online market intervention and interaction was seen through online revenue share. So how the online revenue share was there. So based on it, the interaction was calculated. The next is the business growth. So the sales growth and new customer acquisition was also calculated. So the results showed that productivity has increased by 32% while the intervention was done, but in control it was only 5%. And the digital maturity in all the enterprises, if you see, it was like 1.8 points, and under control it was only 0.4. So the online market share also grew tremendously because of interventions to 40%. And the structured digital roadmaps led to measurable improvements in all the enterprises. If we look at the sectoral differences in outcomes, the retail showed 35% difference in productivity, a very good growth. And the digital maturity was like 1.6. So I already told you the scale is still 5. So 1.6 digital maturity, and there was 45% online revenue. In manufacturing, The highest was for online revenue, 33%, and the digital maturity was 1.9, while the productivity was not showing much. It was like 28% increase. In services, the online revenue is very high, but the digital maturity is good, very good in services, but the online revenue, if you see, increase accordingly. And the productivity, if you see, was much less. The difference in productivity was much less when compared to retail. So the retail benefited most in online revenue, while the services and digital maturity. So the conceptual frameworks goes like this. The core enablers are digital technologies, digital skills, and digital infrastructure. So these help improve, have improvement, efficiency, and competitiveness in business enterprises. And the structural intervention strengthened the MSME flexibility in digital economies. The drive improvements are the business processes, operational efficiency, and market context, which is very much less in these enterprises. And the other one is the resilient, adaptive MSMEs. They lack adaptation of digital economies. So overall, there is less adoption of digital economy, digitalization. The results show. So already I have discussed this. So productivity is high, digital maturity is there, but not to the level that is expected. The revenue is also high. The sector differences already discussed. So if we could see, we see retail, they have very high productivity, and digital maturity is high again in services. So the on-rail revenue is high in retail. The conclusion is structured digital transformation roadmaps have enhanced MSME productivity, and the policy-backed capacity building and low-cost platforms are essential. And there should be collaboration between public and private to increase digital adoption. And there should be a reduction in digital divide to improve competitiveness in emerging economies. Thank you all.
Thank you, ma'am, for your presentation. It's a great, very nice presentation. Now we invite our advisory board and other present members to comments and their queries and questions.
Ma'am, your explanation made complex idea accessible and hallmark of an you are the expert educators. With your permission, may I ask couple of generalized questions to clarify for my understanding, ma'am?
Sure, sir. Thank you. Thank you for your comments.
Why focus on MSME especially, ma'am?
Sir, pardon?
Why focus on MSME especially?
Oh, my focus was in MSME because it's a growing industry now, and government is focusing more on this. So startups and all those schemes announced by our governments are on MSMEs. So since the topic of our conference is also related to digital transformation, so I concentrated how digital transformation is going on in MSMEs. So I just wanted to analyze how MSMEs are adopting that digital transformation.
And generalized question, ma'am. How do you privatize the interventions with a limited budget?
I got the help from other industrial collaborators who helped me with the process. So the budgets, as we know, it's really high, the way of collecting data and all this. So I suppose you're asking how I collected the data?
And what is a smile in a digital roadmap?
The roadmaps were given by the industry. So it's just like that official thing. So I cannot question the documentation. So I have to get on with the roadmaps that the enterprises have given. So based on that, only the study goes on.
Okay. And another question is, what is the minimum viable cyber security baseline for ASME? MSME? मतलब what minimum able cyber security baseline for MSME?
I have not focused on cybersecurity as of now in my paper, but anyhow, if you say, I will try to work on it. Sir. As of now, I've focused only on productivity and the revenue that they generated. So I didn't focus on cybersecurity.
One generalized last question now. In a market access platform versus direct to customer, in your point of view?
Do you want to say whether it's advantages or not advantages? That's what you are asking, sir. Is it a merit or not?
Market access, in a market access के platform versus direct to contact consumer, direct to consumer.
Yeah, direct to consumer is a good concept, but it cannot go on all the time. So sometimes we also need the retailers. I mean, retailers that are going directly. We have all those Amazon, Flipkart, and all coming in. But even then, I suppose there should be a market where customers have more satisfaction. The satisfaction level, as of now, I don't think direct contact will give them whatever they want. That's my personal perception.
Thank you, ma'am, for your exceptional clear presentations, and your explanation made complex ideas accessible. Thank you. Thank you.
Thanks a lot, sir, and thank you, organizers, especially to Sneha Katse ma'am for giving me this opportunity. Thank you, ma'am.
Thank you, ma'am. I invite another members. Can anyone has any question or queries? Please ask the ma'am.
Yes, yes. Hello, ma'am. Very well presentation. It was really good. I like it more. One more question from my side, that how can policies support MSME digital adoption?
Can you repeat the question, ma'am?
How can policies support MSME digital adoption?
Okay, just as I already, the government is already having a lot of schemes concerned with MSMEs, and Digital India is one of the greatest updates as given by the government of India. But as of now, we see the capacity of Digital India is taken up by services sector. So the concentration on manufacturing is much less. So in the analysis, if you see, manufacturing and the retail sector are yet to adopt the digital transformation. So since government intervention is much less in that area. So services is well and good going on. So if this digital policies are applied to services and manufacturing also, overall India will be prospering and will have a good customer satisfaction everywhere. That's it. Thank you.
Okay, ma'am. Thank you so much. If Adipus have any question, you can ask, sir.
No, madam.
Anyone has
Okay, sir. Okay.
question? Please ask. Okay, can we step up to the next presentation? Now I invite the next paper presenter, named Sajita AV. I request the presenter to kindly share their screen and start their presentation. Sajita AV.
Good morning, everyone. Am I audible?
Yes, yes, ma'am. You are audible.
Okay, thank you. My name is Dr. Sajita AV. Thank you for this opportunity to present me here. I will be discussing a critical intersection of the technology in modern industry, explainable AI model for predictive maintenance in smart manufacturing system. We will explore how we can make our most advanced systems not just smart but also understandable. This is our agenda, and as we all know, smart manufacturing has revolutionized the industry. A key pillar of this revolution is predictive maintenance. Simply, we can say PDM. The goal of PDM is to use data-driven insights to fix equipment before it breaks, which is proven to cut cost and maintenance ability. That is, it is minimizing the costly downtime. We achieve this with powerful machine learning models. However, these machine learning models have some limitations. That is, this power comes with a significant challenge. The most accurate model, like deep neural networks, often operate as a black box. So what it say? It's just to give an answer. That is a prediction of failure. So how a prediction is happening, or when it will be happening, and but they don't tell us why it is happening. So this lack of transparency can create a trust deficit with the human operators who need to act on these predictions. So there is a solution for it. So the solution is the explainable AI, or simply XAI. XAI is a set of tools and frameworks designed to bridge the gap between accuracy of our predictions and our ability to interpret them. Instead of an unexplainable black box, XAI provides a clear, simple explanations for the AI's reasoning. As you can see the diagram here in this diagram, it is a this allows us to justify, control, discover, and ultimately improve our system. You can see it can justify, it can control, and it can discover. And through this discovery, we can improve our system. For predictive maintenance, or PDM, this is a game changer. It builds essential trust among operators and empowers them to make better, more confident decisions. The operator can take the better and more confident decision about the failure of that particular machines. Okay. The objectives of the research is that with this context, my research set out to achieve 4 main goals. First, I want to apply this XAI model specifically to predictive maintenance in a real-world smart manufacturing context. And the second one, I aimed to measure their efficiency. Did they actually help reduce downtime and manage resource better? The third, I wanted to conduct an honest evaluation of the benefits and limitations of using XI to improve transparency. And finally, based on my findings, I sought to prescribe concrete measures for improving predictive maintenance with these new techniques. So these are 4 objectives I set for this research. The methodology, I used a quantitative research method. 2 kinds of data sources are used there, the primary data source and the secondary data source. And the primary data source directly from the factory floor, that is sensor readings like temperature, pressure, and vibration collected from IoT, that is Industrial Internet of Things devices. I supplemented this with the secondary data from industry reports and academic literature. For my modeling, I used a range of predictive algorithms, including decision trees, random forest, and more complex neural networks. Critically, I then applied XAI techniques, specifically LIME and SHAP, on the top of these models to interpret and explain their predictions. You can see the result. First, in terms of raw predictive power, my models were highly effective, and you can see it is a 95.2, 98.8, 96.3, and 94.5 rather than other model types. So it is achieving an impressive 95.2% accuracy in predicting equipment failures. This confirms that these advanced models are the right tool for the job, but it also reinforces the need for explainability, as these are often at least transparent too. So the result, unveiling black box with the SHAP. This is where it gets interesting. I used an XAI technique called SHAP analysis to look inside that high performing black box. The results were incredibly clear. You can see the bar chart on the right. Show it is important of different features predicting failure. So why it is happening? Okay, so that is predicting the failure. As you can see, vibration here, 5 parameters are using machine age, operating hours, pressure, temperature, and finally the vibration. And you can see the vibration was by far the strongest predictor, followed by temperature. Factors like machine age, while relevant, were found to be less impactful. This is the kind of insight XAI provides. It moves us from the knowing that the machine will fail to understanding why it is happening. Okay. Then, the impact of XA in practice is that, so what does this mean on the factory floor? It has a tremendous impact. First, it significantly increases the operator confidence. So that's the better way we can use the XA in predictive maintenance. It is increasing the operator's confidence that I can do it. Then when an alert comes in, it is not just an alarm. It is an alarm that says warning, high probability of failure due to the consistently rising vibration levels. So the operator can easily understand that which parameter has the problem, which data points has the problem, how it is happening. This allows the operators to make smarter, more targeted decisions. They can investigate the specific issue, leading to faster repairs and more reliable operations. And he or she can make more customer integrity. Ultimately, XAI makes our predictive maintenance strategies more robust and more readily accepted by the people who rely on them. But as far of any other technology, it has also its own limitations and challenges. The first one is the most significant limitation is the data quality. These models are only as good as the data they can feed. Incomplete, noisy, and biased sensor data can severely undermine their accuracy. Furthermore, the process of collecting and labeling high quality data to train these models can both costly and difficult one. Okay, finally, as XAI is a growing field, there is an ongoing need to develop standardized benchmarks and data sets so we can effectively evaluate and compare different explainability algorithms. So we need some explainability algorithms, but those algorithms are hardly found nowadays. So in my future directions, the next logical step is to adapt these XAI models for real-time systems. Now it is done in the simulation environment. My future scope is to make it in a real-time environment. By leveraging edge computing, we can put these powerful, interpretable insights directly into the hands of the operators on the factory floor in real time. This deeper integration will further enhance the transparency and trust in AI-driven maintenance. I believe XAI can unlock even more detailed understandings of the complex interplay between machine parameters and failure modes, leading to even more advanced maintenance practices. As a conclusion, explainable AI is a critical evolution for predictive maintenance. It moves us beyond a singular focus on accuracy to more holistic approach that values transparency and trust. So trust among the operator and the customer. Okay. By turning our black box model into understandable partners, XAI makes our predictive system more solid, more acceptable, and ultimately more effective. Now it is an emerging technology, and sure, tomorrow it will be in practice in the mid of the operators and the customers. It empowers our human experts, leading to better decisions, enhanced efficiency, and more consistent and productive manufacturing processes. Okay, thank you for your time, and I would be happy to answer any questions you may have. And once again, thank you, Global Research Montias, for giving me such an opportunity. And again, thank you for Sneha Khatse, ma'am. Thank you.
Thank you, ma'am, for your presentation and your time. Now we invite our advisory members and other members for your comments and question and answer.
Ma'am, great presentations. I enjoy the structural and practical takeaway. But my question is that, ma'am, what is a PDM in your word, not a bookish, and how it different from preventive and corrective maintenance?
Pardon me, sir. Questions once more, please.
What is a PDM in your word, not a bookish, and how it is different from preventive and corrective maintenance?
It's a predictive maintenance, sir. Sir, it is telling the operator that not what is happening there, why it is happening, why that failure is happening there. So the operator can take the action step for the future failures.
Okay. And how do you frame the PDM problem, ma'am?
It is using the two XAI algorithms, Lime and Sharp. So Lime is to use to explain individual predictions and Sharp to know the overall importance of each feature in the model's decision.
Means line versus sharp versus integrated gradient. When to use which? Only line, ma'am?
It is used in XAI techniques. It's a XAI techniques which is used for the predictions.
Okay. And which features work well on rotating machineries?
Sir, once more, sir.
Which features work well for rotating machineries, ma'am? This is time domain and frequency band like that.
Yes, it is finding the reason for the failures. Reason for the failures, why it is happening. Means some data points are increasing, their vibration is generating, and the operator can understand that what kind of vibration is generating there. It is an alarm for an operator.
Okay, last question, ma'am. What data to PDM system use and how do you label the rare failure?
Sir, I can understand your question, please.
What data to PDM system use and how do you label as a rare failure?
That means if temperature is increasing, the alarm from normal temperature to extraordinary temperature, the alarm is increasing there. That means an alarm is generating there. That is one data point. And another one is the machine age is another one data point. So based on that data points, an alarm is generating. That's a vibration is generating, and through the vibration, the alarm is also generating there.
Thank you, ma'am. Nice response, ma'am.
Okay, sir. Thank you.
Please, another members, you ask any questions and queries.
Hi, madam.
Hi, sir.
What are the data points you have used? And data points.
Data points used for this one.
Yes. And how you overcome from the noise data for both the machine learning and deep learning algorithms?
Okay, it is the alarm is due to sudden shock or impact.
How
Then
you
another one is that that means it's a alarm is due to rhythmic, that is repeating the vibration pattern. Then this could point a misalignment or unbalanced part.
Okay.
It may be the shock or impact, that is a blockage or foreign object in the machine, or another time the alarm or vibration is generating, that is due to the misalignment or unbalanced part.
Okay. Thank you.
Thank you, sir.
Anyone has any query and question? Can we step up to the next presentation? Okay. I invite another presenter named Renuka and team to present their PowerPoint presentation and share their screen and kindly start their presentation.
Ma'am, please stop your screen sharing, ma'am. Sajita ma'am.
Good morning, everyone. I am Renuka Dhakre. I am currently studying in DRGIT. Our topic is enhancing MOOC engine performance.
Renuka, your slide
Yes.
not visible. Please wait 1 to 2 minutes. Sajita ma'am will stop your screen sharing when you share.
Okay, sir.
Pranjali ma'am.
Yes.
Ma'am, please contact with Sajita ma'am to stop your screen sharing. Then we move ahead.
Ma'am, Sajita ma'am, please stop your screen sharing.
So I think she has stopped. We are able to see the screen.
Sir, I stopped the screen, sir.
But it is
I
visible on my side now.
No, I am able to see Renuka Dakre ma'am's slide.
I stopped it.
I am able to see it. Enhancing moped engine performance.
Okay, ma'am. I think it's
But
network
this is a
issue.
Renuka
Continue.
slide.
Okay. Continue, Renuka.
Continue, ma'am.
Good morning, everyone. I am Renuka Dhakre from currently studying DRGIT. Our topic is enhancing MOOC engine performance, optimizing lubricant system to reduce wear and tear. Presented by Sonali Rathod, Tanvi Taide, and Anuja Darokar. Under the guidance of Professor R.P. Sarode sir and Padgan sir. MOOC engines suffer from higher frictions and heat which causes wear and tear. Good lubrications improve performance and increase engine life. Our aim is to enhance lubrication system for better efficiency. Objectives: to reduce frictions losses, to identify causes of wear and tear, to study aim lubrication system and suggest improvement. Importance of lubrications. Lubrication helps to reduce frictions, control heat, and prevent corrosion, and increase engine life. Then existing system. Most MOOC use a space or wet slump system which oil circulated in crackness, but problems occur like uneven oil flows, oil degradations, and poor lubrications at a low speed. Then problems. Problems like the meter constant at high speed, oil oxidation, and sludge. Then inconsistent oil flow and more maintenance cost. Then slides are represented by the Sonali Rathod. Sonali, please explain.
Hello.
Yes, ma'am. Please continue.
Hello, I am Sonali Rathod. I am starting a new slide. Proposed method, we suggest nano lubricants, better heat transfer, less friction, advanced filters, clear oil, longer life, variable flow pump, adjust oil flow as per load, oil cooling system, stable temperature, synthetic oil, more stable and durable. Design. Our model includes nano lubricant, reserve oil filters, flow pump, and cooling loop for smooth and price lubrication. Experimental plan. Well test, temperature, friction, wear test, fuel efficiency, tools used, lubrimeter, thermals imaging, and oil analysis. Accepted result 20 to 30% less wear, better oil stability, 3 to 5% more fuel efficiency, less maintenance. Benefits: longer engine life, eco-friendly, less oil waste, more customer satisfaction. Conclusion: optimize lubrication, improves engine performance, and reduce wear. In future, AI-based monitoring and smart oil sensor can make it even better. Thank you.
Thank you, sir.
Thank you, Renukta and team, for your presentation. Now I request you, advisory board and other members, any queries and questions you can ask and comments.
Nice presentation, Renuka. But one of the nice presentation, the trade-off you were highlight where the thought is provoking. But my question is, what type of lubricant system are used in a moped?
Mostly a flash lubricant or a wet slub system.
And what happens if lubrications is fail?
Friction and heat increase, causing wear and engine censure.
And what properly of oil affect the lubricant quality most?
Sir, viscosity, it determines film thickness and flow, its flow.
And main functions of the oil, engine oil?
The main functions of the engine oil is lubrications, cooling, cleaning, and corrosion protections.
You are sure for including in cleaning?
Yes.
What can we reduce wear and tear using lubrications?
Sir, by maintaining proper oil level and using correct grade oil and ensuring clean flow through the system.
Okay. Anjana, done on my side. Had great response and great presentations, and also add a very best visual ads.
Please ask anyone if they have an query.
Hello. Yes, can I query now?
Yes.
Yes, actually, it is a good presentation, and I have some questions for the authors. Actually, I want to know why you select this topic.
Sir, repeat please.
Why did you select this topic?
Yeah.
I'm audible now?
They ask you why you select that topic.
Sir,
Hello.
Are you
sorry,
there?
please repeat.
Yes. Why did you select this topic? Can you tell me and you
Why you select the topic?
Sir, I selected this topic because moped engine are very
Hello.
Hello, Renuka. Please check your connection.
Yes, enhanced moped engine performance.
Sir, frictions and heat increase causing wear or a engine servicer. Frictions and heat increase.
Okay, can you tell me what's the added value you provide? Oh, this topic. What is added value?
Sir, please repeat once again.
Okay. What is added value that your topic provide?
By maintaining proper oil level, using current grade oil, and ensuring clean flow through the system.
Okay. What is core objectives or more objectives of your study of your topic?
Best lubrication in moped engine.
Okay. Thank you so much.
Thank you, sir.
Anyone have any question? Ma'am, please stop sharing your screen now. Now we step to the next presentation. Name Dr. Syed Hassam Imam, sir. I kindly request to start their paper presentation and share their screen. Is there, sir, Dr. Syed Hassan?
Thankfully, as he is not available, you can invite to another presenter.
Okay. So we invite our next presenter, named Sudarshan Babar. I request them to please present their paper presentation and share their screen.
Okay, good afternoon. Ma'am, my screen is visible?
Yes, your screen.
Yes, sir. Yes, sir.
Yes. Okay, first of all, thank you organizer for giving me the opportunity to present my paper. So title is Strategic Partnership and Ecosystem for Scaling Agriculture IoT Startups. IoT means Internet of Things. I am presenting on behalf of my co-author, Dr. Satish Angatrao Varfade, which is a research guide for my research project. So, wait a minute. Okay, starting with the challenges or the where I got this idea to create my research paper. IoT solutions promises measurable gains in productivity and efficiency, but startup struggles beyond pilot due to there are few reasons we found out through literature review. The first one is fragmented demand. Second one is low per farmer revenue, high servicing cost, scarce last mile capabilities. So to solve this problem, we propose the solution. The solution is an ecosystem approach orchestrating complementary assets, distribution, finance, data, and trust through partnership rather than the building in-house. Okay, next slide. Okay, before starting the presentation, I want to say which are the part of the ecosystem of the agriculture IoTs. Agriculture IoTs have the few members, farmers and FPUs. FPUs mean farmer producer organization, which are actually end users and cooperatives. Regulators, policy and compliance. Telcos, which are actually providing the telecommunication companies like BSNL, Geos, and all, which provide connectivity infrastructure, insurer and bank, which meet risk mitigation and finance, and input supply, distribution, and trust. So why? The answer is because every startup needs few things. One of is reduce CAC by 35 to 60%. CAC means customer acquisition cost. Actually, how much cost every company or organization need to spend to acquire one customer. The second part is de-risk adoption. Third is unlock financing. And fourth is enable data portability. So objective of the study, build an ecosystem framework mapping critical agriculture IoT stakeholders and complementaries. Second one is classify strategic partnership archetypes and their value to scale, under which we cover the few points like distribution, data, risk, finance, and policy. The third objective is propose governance and data rights, choices that balance openness with quality and trust. The fourth one is provide a practical rollout playbook with unit economic guidance for smallholder markets. And the fifth one is identify policy and DPI enablers and articulate research gap for future works. Here DPI means digital public infrastructure in agriculture, AgriStack, which is supported by government. So, research methodology in which design conceptual multiple case synthesis using secondary data, which is taken from peer-reviewed articles, standard documentations, industry reports, analysis framework, ecosystem map plus partnership matrix, which result into phased rollout playbook, limitations, contextual variability, triangulation applied to the enhanced reliability. So this is the ecosystem of the agriculture where input suppliers, farm agency, tech providers, farmers, even farm decision support system, IoT infrastructure, data aggregators. So actually we are proposing one framework which is called as a partner, which covers product problem fit, in which select crop region which head with acute pain points, access partner with the pure retailer telcos for distribution and trust. Third one is risk sharing, co-design outcome-based pricing with insurers and off-takers. Fourth one is technology standards, adopt open connectivity and APIs for complementary growth, network effects. Then economics, then regulatory rails where eKYC, digital IDs and satellite data reduces cost. So under this framework, these are some archetypes in which distributions which partners with APOs, input retailers and telcos. Value for the startups, lower CAC, cost, customer acquisition cost, higher trust, service logistic. Second one is a data where partners are satellite providers, weather services, OEMs, value feature depth, model accuracy and differentiation. In third, risk sharing, partners are insurance company, off takers, lenders. Finance, in finance, partnership with the banks, NBFCs, fintechs, and policy DPI, where government programs, standard bodies, which will help us. So in governance, there are two types we are discussing: open ecosystem where maximize complementary diversity, faster partner onboarding. In curated ecosystem, higher device with data quality, slower partner growth. So these two ecosystems are compared, and then we are recommending for agriculture IoT startup ecosystem a hybrid model with open APIs and curated devices, app stores, balance growth with quality assurance. So there are few technological terms like long range WAN, NB IoTs, OGC sensor things for interoperability. So phase by phase, if this ecosystem need to implement, then the first phase is beachhead and proof, where startups with life or life age with 0 to 12 months, where narrow crop region focuses partner with one or two high density channels like APOs, telcos, where KPI is payback less than 12 months. In second step, when they cross 12 months, now network effects, open API, onboard complementary. These are the suggestions that ecosystem will accept, the startup will accept. So KPI is attach rate greater than 1.6, churn less than 2% per month. In phase three, multi-sided where startups more than 30 plus months enable marketplace input service carbon credits, launch analytical SDKs and data exchanges, federate across geographies, pursue policy alignment. KPIs, EBITDA, earning before interest, tax, depreciation, amortization, positive cohorts, partner NPS greater than 50. So limitation of the study, as we know, this study is only based on secondary and conceptual evidences. Quantifying impact like CAC reduction are context sensitive. Hardware supply chains and connectivity quality can affect adoption patterns. Publication by towards successful pilots may inflate reported benefits. So these are the limitations. And the scope for the future studies are causal impact studies on IoT bundles, directly on yield and input efficiency, interoperable farmer-centric data trust enabling benefit sharing, carbon ESG monetization, AI augmented agronomy, and the conclusion, scaling of agriculture IoT, just not a device or software, which is actually the phenomena. During my research on agriculture marketing challenges faced by agriculture IoTs, I found that this is the gap where many of the entrepreneur focuses on product development but not on the marketing or business management part like operation supply chain and all. So it needs ecosystem orchestration where if entrepreneur not feeling confidence about the business model like supply chain marketing, then he can tie up with the others which are already members of the ecosystem already we are discussed. Success demand, bottleneck diagnostic, strategic partnership design, open standard adoption, policy alignment and risk sharing model. So the proposed partner framework and three-phase playbook guide startups to escape the pilot trap means product is developed but not scaling. The major problem is scaling paradox, which are already we discussed. So farmer-centric digital platform. These are few references I used for this study. Thank you. And I believe the theme of this our conference is innovation, sustainability, and digital transformation, which is most needed to Indian agriculture. And IoT is one of the way by which agriculture get something that every industry, even industry talking about industry 4.0. I never, as agriculture expert, I never heard about the agriculture 4.0. So these things will help us to design something, derive something, or growth of the agriculture. So thank you. Scaling agriculture IoT requires not just technology, but trust, collaboration, and ecosystem architecture. This is the statement at the end of my study. Thank you. Open for question and answer.
Thank you, sir, for your presentation. Now I invite the advisory board and participants for question and answer.
Wonderful presentation, sir. Your slide made a technical flow very easy to follow. And one of the questions is, sir, what is agro system and how does this connect to manufacturing system?
Actually, whenever in agriculture, we always say there are precision farming things and traditional farming. So agriculture systems, when we connect with manufacturing, there are many agriculture IoT startups focuses on agriculture products. But there is one condition or one phenomena I in my even quantitative study, I find that manufacturer focuses on product, not on the customer. So IoTs and agriculture system, when they are on the same line, then maybe the answer is simple. So manufacturer need to focus on customer need, actual customer need.
Okay, sir. And sir, how can partnership reduce CAC that you mentioned in your slide?
Yes,
No,
customer acquisition
cost.
cost. Yes, sir. The customer acquisition cost. Actually, startups, whenever see startups have the major problem is marketing funds. So they cannot reach, they are focusing on small area. If I want to expand, I want to scale my business, I want to expand through geographical boundaries. So I need, for example, if I am the X startups and I want to expand into the next state, and where I don't have any infrastructural support, I don't have any even an idea about the geography, agriculture condition, climate. So I tie up with the third person, then he will work for me, where I give him some margin, where my cost to set the business unit there will automatically reduces. So which is actually or directly in the financially CSE, so effect on the CSE. So it reduces CSE.
Okay. Oh, what CAC matrix you do track a validate a 35 to 60% reducing claim reduction
These
claim?
are the actually this is from the secondary data, where I found the few papers reported that 35 to 60%. Actually, it need to test on the actual ground basis, but the secondary data shows 35 to 60%, where actual the partner's margin is always affecting.
Okay, sir. And another word are seen in your slide, edge versus cloud. What is trade-off on forms?
Sorry, sir.
Edge versus cloud. What your opinions?
Sorry, sir. Technically, I think I am not unable to answer this question.
Okay. And which business model fit for agri LOT ecosystems?
As a research scholar on the agriculture IoTs, I always believe select the agriculture partner, more focus on the marketing and business point and supply chain. In agriculture IoT, the major problem is after sale services. So if we are accepting this partner framework, so I believe this business model will work for them more profitability. Hello.
So congratulations, Sudarshan sir. I'm having a question. And it was a very good presentation, excellent research work and good presentation. It is out of the presentation that you have done. So my question is, can you share some examples where we can see successful partnerships in the agriculture IoT space as of now in India? Do we have any such partnerships going on? So you talked about collaborations and partnerships for IoT.
Yes, ma'am. Actually, not on the larger scale, or we will call it as on the business model. I have the one example in Maharashtra. The Fasal company have the agriculture IoT products, and he tie up with the Sahyadri Farm, which is FPO, Farmer Producer Organization. So they bought the device which is called as weather forecasting or something, so small devices. So they buy for their farmers, their member farmers, FPOs member farmers, and they install this system throughout their farmers area and all. So they forecast about the weather and the data sent to their farmer and Sahyadri farm. So this is one of the example where if I am the Fasal company, FPO is a direct customer which buy product in bulk quantity. If I want to sell a single farmer, I need more CAC, matlab cost acquisition per customer is high. If I sell directly to the FPO, so it will cut actually the more than we say the procedure or efforts I need to sell my product. This is one example where I found during my PhD study that some companies tie up with the FPOs for direct sale of the product.
Thank you, sir. It was very insightful, and all the best for your PhD.
Thank you, sir. Thank you, ma'am.
Anyone has any questions and queries, please ask the sir. Another members, any queries, please ask the sir. Okay, we can close the paper presentation.
Okay, thank you, ma'am. Thank you all.
Thank you. Thank you, sir.
Ma'am, I have one single question.
Yes.
Hello.
Yes, you can ask.
In farmer motive, what importance of this system? Why they are going see their app?
Okay, I think the question is what is the benefits to the farmer from this ecosystem or this partnership or from agriculture IoTs?
Yes, sir.
So generally, whenever we talk about the agriculture, at the center is the farmer, and everyone focuses on even in government always saying, or even our honorable Prime Minister saying, we are trying to double the farmer income. And in agriculture now in India, the major problem is climate condition. Like Maharashtra last rainy season, everyone knows in news there is a larger impact of heavy rain on the production. So this ecosystem or this agriculture IoTs will help them to reduce few input costs. For example, farmers, even agriculture inputs like pesticides, insecticides. Then they give the advanced weather data where they can manage their production. So agriculture IoT is actually the solution of the many problems in the agriculture IoTs are serious problems there in agriculture. So agriculture IoTs are the solution for it. Now in we know the major problem is fragmented land. For example, I have the 1 acre of land or 1 hectare of land. I can't buy the 10 lakhs, 20 lakhs costing equipment. So if I go with the partnership, cooperative farming or even FPOs, so such cost will be shared, which is profitable for me, which help me to improve my agriculture production, and then we can say their income, then India's food grain needs and all things. So IoT is a technological solution for the farmers. Even there are labor shortage. Even we know, for example, in Maharashtra, if the electricity comes at night 10 p.m. and farmer can't go directly to his farm in such conditions, so he can at home one device which is called as agriculture by mobile phone, he can start his motor irrigation system. Such things are minor. Many people think directly connect with the income, few things for convenience and all. But agriculture IoT is something which we call a need of our farming system because the problems farmers are facing very high. Hope Hope I
Sir, one last.
answered you.
Hello?
Yes, yes.
Sir, one last question. Sir, in
Yes,
our
yes.
India, farmers 70% have no phone and any communication device.
Yes.
They are going internet. So, sir, why you reach them people in their villages?
Okay. The major issues are in technical language, we say technology adoption model, TAM way where I said there are many limitations. For example, internet connectivity or even the age factor. Many farmers which age is more than 60 not using mobile phone. If they are using mobile phone, they are using the basic phones with the button, no smartphones. So generally, this is in nascent stage. For example, now IoT is introductory stage. But after 5 to 10 years, if this generation passes and take over their parents as a agriculturist, they will use this. So this is a new technology. And now if we are focusing on few customers, after few years with their experience, this technology diffusion rate is high. Maybe many people will use this. We can't say this technology for everyone, but this technology for those who are trying to implement new technology in agriculture. So slowly it will the number will raise. As of now, yes, there are many farmers who even don't trust. Even I have the smartphone, but I don't want to trust this technology. They don't use it. But slowly, with the result, with the we say something we call as if I am using, I tell 10 farmer that yes, this technology is very good. So slowly, expansion of this technology will growing on. As of now, it is nascent stage, so we can't say it is for 100. It is for everyone. Yes. Any question?
Thank you, sir.
Okay. Thank you.
Thank you, sir. Anyone has any query and question? Please ask. So, I think no one has any question.
Okay. Thank you, ma'am.
Thank you. Thank you all the advisory board and participants to manage their time and use their precious time for this presentation. Now we move. Sorry. Now we move to the last part of our presentation and conference. The last part is conducted and guided you by the coordinator 1, Ma'am Jayashree. Now she can discuss and she can give the best award name. They can present their presentation best, and she now tell you the name of the best presenters. The best paper and announcement is done by Ma'am Jesh.
Thank you, Pranjali ma'am. Now move toward the award and closing ceremony, best paper and announcement. We have reached the concluding part of this academy gathering. We are delighted to announce the best paper award selected by our review committee based on originality research, depth and presentation. First presentation award goes to Anita ma'am.
Congratulations, ma'am.
Congratulations, ma'am.
Congratulations, madam. Have a great explanation from the MSME.
Thank you, the whole board and the team. Thank you for awarding this to me. Thank you.
Second presentation award goes to the Vaishakhi and team.
Congratulations,
Congratulations,
Vaishakhi.
Vaishakhi.
Congratulations.
Congratulations, Vaishakhi.
Congratulations.
Congratulations, ma'am.
Third presentation goes to the Sudarshan Barber sir.
Thank you all.
Congratulations, sir.
Congratulations, sir.
Congratulations, sir.
Congratulations. Congratulations.
Thank you all.
Congratulations, sir.
Thank you, sir.
And last presentation award goes to the Renuka and team.
Congratulations, Renuka and team.
Congratulations, Renuka.
Thank you,
Renuka
sir.
and team. Congratulations.
Congratulations,
Congratulations,
Renuka.
Renuka and team.
And team.
Congratulations, Renuka.
Then last and vote of thanks. Vote of thanks. On behalf of SCI Scrap Publication, we extend our heartfelt gratitude to our Chief Editor, Advisory Board member, all presenters and participants for making this conference a success. A special thanks to our organizing team and technical support members. We hope this conference has sparked meaningful collaborations and new research direction. We look forward to seeing you at our future event. Thank you all and have a wonderful day ahead. Thank you all. Participant presenters.
Thank you
Advisory
all.
board.
Thank you all.
Thank you all for participation.
Thanks to all
Shall I-
advisory board members and technical teams, even the coordinators, very well. So it was a great conference for us. Thank you so much for coming and joining us. All presenters also, congratulations who got the paper presentation award, best paper presentation award. And once more, congratulations and thanks to all of you.
And one more request, please start all of your video. Then I take a screenshot. Thank you. Thank you. Thank you. Shall I leave, ma'am?
Yes, now all can leave. Thank you so much.
Thank you.